CAD for Dreaming Out Loud, video 5. I'm Mark Wilson. On the screen we have a moulded part. It's an injection moulded part. It's a cover of some electronic device. It was supplied to me by one of my ex-students, and thank you, Charles. It's a wonderful part. And I did some input into the design of this, but essentially it's my student's work. But what I'm interested in here is producing an injection molded part from an injection molded tool based on this particular part here. Now I've looked at Alibre, which is the program I'm using, and it has a thing called Boolean or Boolean, and it has these particular aspects. It has a Boolean unite, has a Boolean subtract, and a Boolean intersection. And you can sort of work out from that what that's going to do. Now, in their instructions in the videos and what have you, it talks about molded parts, but in particular things like that are cast, not necessarily things that have a fairly complex core underneath them. And you can basically import a part, like an assembly basically, and subtract that from something or other, from a block, and consequently create a mold. And in simplistic terms that's all very fine, but it has some added complications when you're dealing with injection molded parts, trying to produce a shut face and all sorts of things. So let's investigate, and I'll come up with a bit of a way of doing this, and I don't know if it's right or wrong, but we'll give it a go. I'm going to close this down at the moment. We'll close the window. So I've imported this particular part here. It's basically a block, and I'm going to ignore lots of things about injection molds that you have to factor in, things like shrinkage rates and things like that. This is just an exercise to see if I can create a working cavity and core suitable for injection molding. So I have my original block, and I've worked out basically the overall dimensions of this to suit basically this particular part. It's way longer than I need, but we'll just ignore that for the moment. We're ignoring shrinkage or anything like that. We're ignoring lots of things, and we're just going to go and cut to the chase and see if I can make a workable cavity and core based on that particular model that we had before. We'll go to Boolean, and first of all we'll go to Boolean subtract first, because what we want to do is subtract this particular part from this particular block here. We'll go Boolean subtract, and we'll need our part. Now when I imported this part, I tried an IGES first, and the IGES wasn't terribly good. That didn't work terribly well. I tried a step file, and that didn't work terribly well, and then I tried a parasolid, and this worked reasonably well. So this is a parasolid that I received from my student, and this one here works quite well. So we'll give this a go, and I have rehearsed this before, so yeah, ignore all the it all should go fairly smoothly, but we'll see how we go. So we're just going to import this particular part. So there's my part. It's already come up on the screen there. We'll just go finish. It's already selected one of these here. Sometimes it selects, sometimes it doesn't. Now what we would like to do is have this part immersed in this, so that the split line, or this area here, becomes the surface face where the two halves of the mold separate. So what we want to do is have this sort of immersed in here. Now I could put this in a solid block, this block going up here, but that's not really going to help us because it doesn't create a moldable thing that would work in an injection mold. So we're just going to immerse this in here like in a tub of water, and see if we can get this to work. So we'll need to there's my part imported there. We'll need to basically shift this thing around here. We'll flip this over, and I'll select this bottom part here. That's where the mold is going to separate, this face down here. So we'll select this particular face here, and go back into isometric, and we'll click that face there. I will select the that face there. That's the same one on the same thing, and at the moment it's basically locked onto that face there, but we would like to flip that upside down because it's basically going to be a cavity. So now it's upside down, and we'll press the accept on that. Now to get this lined up as well, that top face there is now that face there. We will also, we'll just go onto there, right click, and we'll show reference geometry of the part itself. We'll go back into the constraints. We've selected that. Now we're just going to get out of this here, clear all. And what I would like to do is have these planes here locked into this part here. So we'll go into, we'll select that plane there and this plane here, and we'll accept that, and we'll select this plane here and that plane there, and there is my part, sort of like it's submerged in water basically, and we'll accept that particular process here. So there's my part buried in the cavity block, but what they're about to tell you in the instructions on here is how to remove this section here, which would have to be on the core side, or the we call this side here the the fixed side of the tool, because it doesn't move, and the side with the ejection on and what have you as the moving side. So this is the fixed side of the tool where the plastic is ejected from. But we want to remove this particular part here so that we can make a working cavity here. Now at the moment our part, and I'll just demonstrate what's wrong with this part here and how we can't just use it as is. I'll go into make this a little bit more translucent, and you can see what's going on below the surface here. There is our part immersed in here, and it's subtracted from this block here, so it's basically the equivalent of fresh air. But at the moment it's attached by this tunnel through here, and also by these buttonholes for this particular part here, is making it all one component. So if I try and subtract a separate component here, it's not going to work. Now in injection molding, and I'm a tool maker by trade, it's a good idea to sort of create a nice simple shut face that basically makes it easier to work around here. So what I'm going to do is I'm going to basically do a create a cutout that runs all the way through here to do this tunnel, and we'll ignore what happens in the middle here. We'll just use that cutout for purposes of making it work anyway. So we'll just go into sketch. We'll select this end face here, and you can see our part there. We're going to make a circle around our origin point there, and we're going to make this circle 6 mm in diameter. Now let's go in a little bit closer and we'll have a look at this part here. The tunnel itself there's an electrical groove thing going through here. This is the tunnel itself, I believe, here, where this electrical cable is to run through. And of course our part we're going to make is a lot bigger than that, and you'll see why down the track why I've done this. But we've made we're going to make material here. We're going to cut out material, sorry. We're going to accept that sketch here, go into the isometric view, and we're going to extrude cut that through all. Okay. And that makes a tunnel through here. Now that effectively isolates this section here from that one there as well, and makes a tunnel groove all the way through this particular block here. Now that's kind of what we want, but we'll deal with a few other issues as well. So not only now this part is disconnected here, we now want to remove or disconnect it through here for our buttons, which are still connected to the main block here. So if I come on and do another sketch here, we'll select the top surface there. we'll come down to this particular top button here. We'll make a rectangle. And just because of time constraints, I'm not going to tie this in. We're just going to make a rectangle. I'm not going to tie it all in. We want to do an extrude cut down to the top of that buttonhole there. Extrude cut. And we want to go, we've got the sketch there, we'll go to geometry. And we can see our part, there is our buttonhole there. We're just going to go right click, advanced selector, and we're looking for the face of the buttonhole, which is, where is it? That one there. And we'll go OK. Right, there we have a cutout in here that's basically going down to the top of that buttonhole there. There it is there. So now we've isolated that portion there. The only thing that's connecting now are these two buttonholes here. So let's just make another sketch. We'll select the front face there. Zoom in a little closer and we'll make another rectangle there, just covering these buttons here. Now I just pull that out just a little bit further. Now apologies to people who like things locked in, but I'm just doing this for the sake of getting this done quickly. Backspace there, selector, and we just pull that out a little bit wider. There, that should cover that, and we'll accept that sketch. We'll do another extrude cut, and this time I will go to geometry. But I do want to point out something. There's a little bit of a 0.25 radius on the top of that buttonhole. So it's not just that face. I want to go 0.25 further. So we're just going to go to geometry. Geometry. We'll go to the advanced selector. And we want that particular face there. And we're going to go offset by 0.25. OK on that. So that effectively isolates this particular section here. So now I'll just take this back out to make this completely opaque so you can see what we've done. Okay, there's our part with these sections chopped out here, isolating this particular lump here. Now there's a few more lumps here. They call them lumps. So I don't know why they call it lumps, but that's a thing about Alibre. So what we want to do is isolate the lumps here. So now if this is separate, we need to get rid of this. We'll go that there, remove pieces. We want to take out this piece here, which is lump, okay, and we want to go OK. Now there's a couple other things here. There's a couple of holes which are core pin holes that don't actually connect to the other side of the tool as well. They are separate parts. We will get rid of those as well. So we just go to isometric again. Come in a little bit closer, and we're going to also remove this particular piece here, that one, this one, and this one. Okay. So that basically is a cavity of an injection mold, and now we want to create a core. Let's just save that. Right, so we've saved that. Let's go and save as. We'll do a save as, save as, and we're going to another part, and we are going to put it into, I'll just put it into separate, make a new folder here in this particular one here, in this one here, and we're just going to call that A for the sake of it. Okay, so in OK here, we have another folder in A, so it's not doubling up over here, and we'll just go OK. Now let's call up that one we've saved as. This is now a new part. Just going to go close window here. Let's open up in folder A this particular part here. So 2 copies of this cavity. Right. Now, theoretically speaking, if I import or boolean the existing molded part into this, and then create a core subtracting the molded part from this, it will create a core with the appropriate side of the tooling active. So what we're going to do now is go to Boolean. We want to unite here. And we want the existing part, this one here. There's our part again. We're just going to click that there and go finish. And what we want to do is basically place that part into this cavity here and basically make it the one block here. So we'll go into the assembly constraints. We will basically select once again this bottom face down here, that face there. We'll go back into the isometric again. We'll select this face here, and of course we want to flip this thing upside down. There it is, upside down. We now, I'll just put on the, I'll just accept that. I just want to put on the right click here, the advanced selector. No, it's not the advanced selector. This, we want the geometry. Close that down here. Select on that part there. Right click and show reference geometry, because that's what we use to locate the last part here. And of course we're ignoring shrinkage and all sorts of things. This is just an exercise to see if we can do it. We want now, we have that, we want to now align that reference plane there with this particular reference plane here. That didn't work out right. We'll just undo that. We went the wrong way around. We'll select this reference plane here with that reference plane there. We'll accept that. And we're going to select this reference plane here with that reference plane there. And of course that moves in there. And now we have our part placed into the existing basically cavity, and we're going to accept that. And of course that then will become all the one color. It does take a little while. Now we have the part effectively part of the same block now. So now we have effectively something to make the core out of. Let's save that and we'll close that one down. Now, what I want to do is make a core. So let's just go into our measure here and we'll select the core of this particular part. This is one I prepared earlier. This new part here. And this should just be a plain block. So there's our plain block. So it's just a block. It's double the height of the existing one. So this bottom part here would be our cavity area. We now want to bring in that welded part with the cavity and Boolean subtract this from this particular block here. So we're going to go into Boolean subtract. We will then select the particular part I want, which is this one here. We want this particular part here. So there's my cavity block with the component basically welded to it. What we want to do now is to overlay that over the top half of this. So we'll just go right click first and we'll put in the reference geometry of that part. We would like to see this particular part here, that face there, aligned with this one here. And we'll just flip it over the other way, just so that it looks, it'll come out looking right. We'll go OK on that. We'll select this particular plane here and that one there and line that up. And we'll accept that. And then this plane here and that plane there. Okay, and we'll accept that. So now, if we close that there, and we hit the accept on the Boolean subtract, hopefully it will do the right thing. Right, and there we have it. There's our cavity block and core block for this particular thing here. Now, if you look a little bit closer, you can see that there's no hole here because there was no radius in the corner there, but this is raised up to 0.25mm for that tiny little radius there on the edge, which may not be a useful thing in tooling situations. We'll have to put some core pins and things like that. But if you look here, you'll see here on this area, we have the section here with a shut face coming over larger than where this electrical cable is going to come through here. And in regular tooling, you would tend to make a larger section here and then localize EDM this particular area here, making sure that you got exactly the shape of the cable you wanted, rather than relying on the shut face dictating what it actually does. It's just a tooling thing. Now there is a little bit of an issue with the reverse draft on this particular face here, on that face there, but it's not a consequential thing. It's not going to interfere with this here in any way, shape or form. The draft will go the opposite way, but on such a small area it's not noticeable in the part, and that's just general practice to make a wider shut face area and then localize EDM this particular area here. And so there you have it. I believe this is one of the ways of doing it. There might be better. I'd be welcome for any sort of input as to whether I'm doing the right thing or the wrong thing. I would then go and create an injection mold based on this. I have now a cavity and a core, and tell me what you think. I'm Mark Wilson, and thanks for watching.